Hi my dear students in grade 6. Now we are going to make our mathematics exam review worksheet. We are going to solve exercises in this worksheet. Hope you do well in your semester 3 exams. The topics covered in the semester 3 exam for the mathematics subject. We have chapter 2. The title is Straight Lines and Circles. In this lessons we've studied about circles, the center of the circle, special lines in the circle that like the radius, the diameter, what is an arc, what is a chord, how we draw a secant, what is a tangent, the definition of the tangent, how we draw a tangent in a circle. In chapter 7 we have lesson which is fractions 2. In this lesson we've revised together from last year addition and subtraction of fractions, how we add and subtract fractions, like fractions and unlike fractions. And for this year we've studied multiplication of fractions, how we multiply two fractions and reduce them. Then we've studied division of fractions, how we divide two fractions, the steps to perform division. In chapter 8 we've started talking about relative numbers or signed numbers. We've seen what are relative numbers, positive numbers and negative numbers, what is a numerical axis, how we locate points, relative numbers on a numerical axis, and how we compare relative numbers, all the cases of comparison. Now we are going to start our exercises. Question number 1, we should indicate whether the following statements are true or false. Not only this, we should correct the false ones. On a numerical axis, all the positive numbers are to the left of the origin. So this statement is false because on a numerical axis, all the positive numbers are not to the left of the origin, they are to the right of the origin. The diameter in the circle is a line that cuts the circumference in one point. First, the diameter is a line that passes in the center of the circle, passes in the center and cuts the circumference of the circle in not one point, it cuts the circumference in 2 points, so this statement is false. Minus 7 is a negative number. We look at the sign of minus 7, it's minus, so this statement is true because all negative numbers are preceded by a minus. In the circle, the radius is equal to the diameter divided by 2. Also, this statement is true. Like fractions should have the same numerators. When we want to know if two fractions are like fractions, we should look at the denominators. Two like fractions should have the same denominators. So this statement is false. Plus 5 and minus 4 are two opposite numbers. We all know that opposite numbers have the same numerical part. So if this is 5, this one should be 5, and they have opposite signs. The first one is positive, the second one is negative, so this is false. Now in question number 2, we should observe the figure 1. If we look at this figure, we can see a drawn circle with many lines in this circle. After observing it, we should now complete the following sentences. Point M is exterior or interior to the circle. This is point M. We can see that M is inside the circle. It means that point M is interior to the circle because exterior means outside. Now segment BC. If we look at segment BC, we can see a line passing in the center of the circle and cutting the circumference in 2 points. So BC is a diameter in the circle. Now point O represents the center of this circle. Now segment EF, we can see that segment EF cuts the circumference in 2 points without passing in the center of the circle. So EF represents a chord in this circle. It is a part of the secant inside the circle. Now OA, if we look at segment OA, it is a line from the center of the circle cutting the circumference in 1 point. So OA is a radius in the circle. Now line D, if we look at this line D, is it interior to the circle or exterior to the circle? Line D is outside the circle, so it is exterior to the circle and not interior, because exterior means outside. Now line L, if we look at line L, we can see that L touches the circle from outside in 1 point, which is A. So L is a tangent because the tangent touches the circle in a point at point A. Now line D, if we look at line D, it cuts the circumference in 2 points. So line D is a secant in the circle. Now, if we are given any circle of radius, the length of the radius is 5 centimeters. We should calculate the diameter of this circle. We have a rule, and we all know that the diameter in the circle is equal to the radius times 2. Equal, the radius is 5, we multiply 5 by 2. If the radius is 5, so the diameter of this circle will be 10 centimeters. Now question number 3. Question number 3, it talks about the relative numbers and how we can locate relative numbers on the numerical axis. Given the following numerical axis, we all know that the numerical axis has a very important point, which is O. This point is called the origin of the axis. Now, all the positive points are located to the right of the origin, and all the negatives are located to the left of the origin. Now, in part A, what's the origin of the axis? The origin of this axis, as we said, is point O. What is its abscissa? Always the abscissa of the origin is 0. Don't forget that we write the abscissa between parentheses. Now on this axis we are given points A, B, C, D, and F. We should find the abscissas of these points. First, the abscissa of A. A is in the negative side, so A has an abscissa of -1. Point B is on the positive side, so point B has an abscissa 3 or +3. Point C is in the negative side. The abscissa of C is -5. Point D is in the positive side. Its abscissa is 5. Point E in the negative side, its abscissa is -3. Point F is in the positive side and its abscissa is 7. Now, what can you say about the 2 points C and D? This is point C and this is point D, because they have different abscissas or opposite abscissas. So C and D are symmetric to each other with respect to the origin of. Any two symmetric points, what can you tell about their abscissas? Their abscissas will be opposites. Their abscissas are opposites, because one is +5 and the other is -5. Now, in part E, we should locate the point S, which has an abscissa 1. It's in the positive side, so we write an X. It's on the abscissa 1, we write S. P has an abscissa -6. It's in the negative side, So we write an x on minus 6, and this is P. R has an abscissa of minus 4. It's also in the negative side. So this is R, which has an abscissa minus 4, and T has an abscissa 4. So this is T having an abscissa 4. Now, what is the distance OB? The distance is how far the point is from another one. If we look at the origin O and this is B, we count 1, 2, 3. So the distance is 3. We don't care if the point is in the negative side or in the positive side, because always the distance is positive. OC, it is 1, 2, 3, 4, 5. So OC is 5. Now AC, this is the distance AC from A to C. 1, 2, 3, 4. So the distance AC is 4. The distance CD, this is the distance CD from C to D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance CD is 10. Now the distance BD, this is the distance BD. We count 1, 2. So the distance BD is 2. The distance AE is 1, 2. So the distance AE is also 2. Now in part G, we should find the opposite of minus 9. Always the opposite has the same numerical part but a different sign. If this is minus 9, so its opposite is plus 9. Now the opposite of plus 3 is minus 3. The opposite of 0 is 0, because 0 has no sign, no positive nor negative. Opposite of 7, 7 has no sign, so it is positive. So the opposite of 7 is minus 7. Opposite of minus 2. First, the opposite of minus 2 is plus 2. So what's the opposite of plus 2? It is minus 2. Now the opposite of 4. What's the opposite of 4? The opposite of 4 is minus 4. So the opposite of minus 4 is plus 4. Now, from the numerical axis, we should name two symmetry points. Other than C and D, we have E and B are symmetry. E and B are symmetry. We can say that A and S are symmetry. These are symmetry points on the numerical axis. Now let's compare these relative numbers. We have plus 6 and minus 4. Here the sign is positive and here the sign is negative. Whenever we compare a positive with a negative, always the positive is greater than the negative. 0 and the plus 3, always the 0 is less than all positives. Minus 5 and the plus 1, all negatives are less than all positives. Plus 0.9 and 0, all positives are greater than 0. Minus 4 and 0, always all negatives are less than 0. Now, minus 11 and 6, all negatives are less than all positives. Plus 8 and 8, 8.0 means it is 8. So plus 8 and 8, they are equal. Minus 7.80 and minus 7.8, here we cancel the 0. Both are negatives and they are equal. 0 and minus 13, always 0 is greater than all negatives. Minus 6 and plus 6, all negatives are less than all positives. Now 4 and 7, in the positive side, as we go nearer to the 0, the number decreases, so 4 is less than 7. Plus 9 and the plus 3, 9 is farther from 3 than 3 from 0, so plus 9 is greater than plus 3. In the negative, as we go farther from 0, the number decreases, so minus 7 is less than minus 4. Minus 1 is greater than minus 5. 4 and minus 13, all positives are greater than all negatives. Now represent the following by a relative number. 7 meters above the sea level. The word above means more than 0, so this is a positive number, plus 7. 10 steps down. Down means negative, so this is minus 10. Inferior to 5. Inferior means below 5, so it is minus 5. Loss of $50. Loss means we lose. This is negative, so minus 50. 12 meters under the ground. Under means below 0, so this is minus 12. Benefit of $30. Benefit means we gain, so this is plus 30. Superior to 0. Superior means above 7. Sorry, superior to 7. Superior means above 7, so this is plus 7. Now we should order the numbers in increasing order. Increasing order means from smallest to greatest. Now the smallest is negative. It's either minus 7, minus 7.5, minus 2, minus 7.05, minus 4, minus 7.35. The smallest of these is the farther from 0. Which is farther from 0? So we start with minus 7.5. It's less than minus 7.35, less than minus 7.05, less than minus 7, less than minus 4, less than minus 2. Now we have 4, 0, 7, and 7.5. Before we move to the positive, we should write the 0 between the positives and the negatives. Now we have 4, 7, and 7.5. It's the nearer to the 0, so 4. Then we have 7, and the greatest is 7.5. Now in question number 4, we should perform operations on fractions, and we should not forget to simplify or try to reduce the result fraction if possible. First, we will start with the first group, which is addition and subtraction of fractions. In addition and subtraction of fractions, here we have two cases. We have like fractions and we have unlike fractions. Like fractions, we directly get a result fraction its denominator as the two given denominators. Unlike fractions, we change into like. Then we add or subtract. Now we are going to start. 2 over 7 plus 4 over 7. Here the denominator is 7, the denominator is 7. So these are like fractions. We directly get a result fraction and its denominator is 7. 2 plus 4 is 6. 6 over 7 is an irreducible fraction because 6 and 7 are successive numbers. 5 over 12 plus 4 over 12. Denominator 12, denominator 12. So these are like fractions. We get the result fraction. Denominator is 12. 5 plus 4 is 9. So 9 over 12. We can reduce both factors by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 3 over 4 is an irreducible fraction. 3 over 8 plus 3 over 8. Denominator is 8, denominator is 8. So like fractions, we directly get the result fraction, denominator 8. 3 plus 3 is 6. 6 over 8, we can reduce both terms of the fraction by 2. 6 divided by 2 is a 3, and 8 divided by 2 is 4. 3 over 4 is an irreducible fraction. Now subtraction, like addition. We look at denominator 1 and denominator 2. These are like fractions. We directly get a result fraction, denominator 5. 4 minus 2 is 2, so 2 over 5 is an irreducible fraction. 7 over 10 minus 3 over 10. Also denominator 10, denominator 10. These are like fractions. So in the result fraction, the denominator is 10. 7 minus 3 is 4. 4 over 10. We can reduce both terms by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. 2 over 5 is an irreducible fraction. Now, 13 over 15 minus 4 over 15. Denominator 15, denominator 15. So these are like fractions. In the result fraction, the denominator is 15. 13 minus 4 is 9. 9 over 15, we can reduce both terms by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 3 over 5 is an irreducible fraction. Now 3 minus 4 over 6. 3 is a whole number. We should change it into a fraction, so we write 3 over 1. Now here the denominator is 1, the denominator is 6, so these are unlike fractions. We change the unlike fractions into like fractions. How? We multiply all the first fraction by the second denominator. So we multiply this fraction by 6, both terms, and the second fraction we multiply it by the first denominator by 1. 3 times 6 is 18, 1 times 6 is 6, minus 4 times 1 is 4, 6 times 1 is 6. Now we have like fractions. We get the result fraction, denominator 6. 18 minus 4 is 14. 14 over 6, we can reduce both terms by 2. 14 divided by 2 is 7, and 6 divided by 2 is 3. 7 over 3 is an irreducible fraction. Also, we change 5 into a fraction. These two fractions are unlike fractions. We change them into like fractions. We multiply the first fraction by 1, and we multiply the second fraction by 9. 7 times 1 is 7. 9 times 1 is 9. 5 times 9 is 45, and 1 times 9 is 9. Now we have like fractions. So the result fraction, denominator 9. 7 plus 45 is 52. 52 over 9 is an irreducible fraction. Now 6 over 8 plus 1 over 4. These two fractions are unlike fractions. We change them into like. So times 4 times 4 times 8 times 8. 6 times 4 is 24. 8 times 4 is 32, plus 1 times 8 is 8, and 4 times 8 is 32. So these are two like fractions. In the result fraction, denominator is 32. 24 plus 8 is 32. The fraction 32 over 32 is a whole unit, so it's equal to 1. Now 15 over 4 minus 3 over 2. These are unlike fractions. We change them into like. We multiply the first fraction by 2 and the second fraction by 4. 15 times 2 is 30. 4 times 2 is 8. Minus 3 times 4 is 12. And 2 times 4 is 8. Now we have like fractions. The denominator is 8. 30 minus 12 is 18. 18 over 8, we can reduce both terms by 2, so we get 9 over 4. Now in multiplication of fractions, we should multiply in a big line of a fraction, numerator 1 times numerator 2 over denominator 1 times denominator 2. Then on this fraction we try to reduce the if we have a common factor between the numerator and the denominator. 7 over 9 times 4 over 5, we write a big line of a fraction. 7 times 4 over 9 times 5. Is there any common factor between 7 over 9? No. Between 7 and 5? No. Between 4 and 9? No. Between 4 and 5? No. So we multiply numerator times numerator. 4 times 7 is 28, and 9 times 5 is 45. 28 over 45 is an irreducible fraction. Now 8 over 9 times 15 over 6, big line of a fraction. 8 times 15 over 9 times 6. Is there any common factor between 8 and 9? No. Between 8 and 6, they are both divided by 2. 8 by 2 is 4 and 6 by 2 is 3. Between 15 and 9, they are both divided by 3. 15 by 3 is 5 and 9 by 3 is 3. No more common factors. Now we multiply. 4 times 5 is 20 and 3 times 3 is 9. 20 over 9 is an irreducible fraction. Now we multiply 12 times 15 over 10 times 8. Any common factor between 12 and 10? They are both divided by 2 is 6, by 2 is 5. Between 6 and 8, they are both divided by 2 is 3, by 2 is 4. Between 15 and 5, they are both divided by 5. 15 by 5 is 3 and 5 by 5 is 1. No more common factors. 3 times 3 is 9. 1 times 4 is 4. 9 over 4 is an irreducible fraction. Now 2 and 3 over 5 is a mixed number. We should change it into a fraction. We multiply the number by the denominator and we add the numerator. 2 times 5 is 10 plus 3, it's 13 over 5 times 5 over 13. We multiply on a big line of a fraction. 13 times 5 over 5 times 13. 13 by 13 is 1, by 13 is 1, 5 by 5 is 1, and 5 by 5 is 1. So 1 over 1 equals 1. The two fractions, 13 over 5 and 5 over 13, are reciprocal fractions. Because of that, their result or their product is 1. Now, 3 and 2 over 4 times 1 and 1 over 6. We change the mixed number into a fraction, the first one, and also the second one, we change it into a fraction. 3 times 4 is 12, plus 2 is 14 over 4, times 1 times 6 is 6, plus 1, it is 7 over 6. On a big line of a fraction, we write 14 times 7 over 4 times 6. Now, is there any common factor between 14 and 4? They are both divided by 2. This is by 2 is 7, and by 2 it is 2. No more common factors. So now we write 7 times 7 is 49, and 2 times 6 it is 12. Now we will perform division of a fraction. In division of a fractions, we have 3 steps. Step number 1, write fraction 1 as it is. We should write fraction 1 as it is. Second step, we change the division into multiplication. Step number 3, we write the inverse or the reciprocal of the second fraction of fraction 2. Now we have multiplication. Now we multiply as we did in the slide before. So in division of fractions, we have to write, this is fraction 1 and this is fraction 2. We write fraction 1 as it is, 12 over 7. We change the division into multiplication and we find the reciprocal of second fraction, 8 over 5. The reciprocal means, or the inverse means, we shift both numerators and denominators. So 8 over 5 becomes 5 over 8. On a big line of a fraction, we multiply 12 times 5 over 7 times 8. Any common factor between 12 and 7? No. Between 12 and 8, they are both divided by 4. 12 by 4 is a 3 and 8 by 4 is 2. No more common factors. 3 times 5 is 15 and 7 times 2 is 14. 24 over 11 divided by 18. First we write 18 over 1. This is the first fraction, this is the second fraction. We perform the 3 steps. Write the first fraction as it is. We change division into multiplication and we write the reciprocal of the second fraction. Now we multiply on a big line of a fraction. 24 times 1 over 11 times 18. Any common factor between 24 and 11? No. Between 24 and 18, they are both divided by 6. It is 4, and this is by 6. It is 3. No more common factors. 4 times 1 is 4, and 11 times 3 is 33. Now, 4 and 2 over 5 is a mixed number. We change it into a fraction before we perform the steps. 4 times 5 is 20 plus 2 is 22 over 5 divided by 8 over 15. Now we perform the steps. We write the first fraction as it is. We change division into multiplication and we find the reciprocal of the second fraction. Now we multiply on a big line of a fraction. 22 times 15 over 5 times 8. Is there any common factor between 22 and 5? No. Between 22 and 8, they are both divided by 2. It's 11. By 2, it's 4. Between 15 and 5, by 5, it is a 3. By 5, it's 1. So 11 times 3 is 33. 1 times 4 is 4. Thank you, my dear students. All my love. I hope you do well in your mathematics semester 3 exams.